In this video, you're going to learn about something called Phoenix LiveView. So what's Phoenix LiveView? Well, it's a library for creating web applications that need to provide rich, real-time user experiences similar to what you can achieve with single-page apps. Now, before we start to look at what LiveView is in more detail, I want to first consider the problems that Phoenix LiveView solves. Oh, one more thing before I get started. Phoenix LiveView works with the Phoenix Web Framework, which is written in the programming language Elixir, but you don't need to know Elixir or Phoenix at all to watch this video. In fact, this video is specifically for web developers who don't know Elixir. To get a sense of the problems that Phoenix LiveViews solve, I want to walk you through a little thought exercise. So imagine you've been tasked with building a basketball scorekeeping web app that looks kind of like this. Basically, there's 3 pages in this app, as depicted in these rough wireframe drawings. Let me explain how this app should work. There's a home page which shows box scores for the active games, and from this page, you can either start a new game by clicking this button, or you can view the details of an existing game by clicking anywhere in a box score. If you click on this New Game button, you'll be taken to this page where you can do things like change the quarters, assign each team a name, you can add players, and you can keep score by clicking these 2 and 3 point buttons. And essentially, this page is the scorekeeper page. Now, back on the home page, if you click on one of these mini box scores, you'll be taken to this page, the game detail page, which shows you the game score and provides additional details about the game. When a player scores, the scorekeeper will need to click the 2 or 3 point button for the player that scored. Then the score should be updated here, and the play should get added down here, but that's not all that needs to happen. Additionally, the new score should be updated in real time, both on the home page and on the game detail page. Okay, now that you've got the basic gist of how this application should work, I want you to answer this question. What kind of an application would you write to solve this challenge? Would it be a traditional server-rendered multi-page app, or would you use a single-page app? I bet the vast majority of people watching this video would choose to implement this as a single-page app using something like React, Vue, Angular, or any of the other front-end libraries or frameworks. This scoreboard app isn't very complicated, but it does offer a richer, real-time user experience that would be hard to implement in a multi-page app, but offering this rich real-time experience is totally doable with a single-page app. In fact, I bet most seasoned web developers watching this video picked the single-page app approach without giving it much thought. I probably would have made the same choice myself a few months ago, but I'm going to ask you to question your assumptions and reanalyze this choice, considering the fact that there's a new option called Phoenix LiveView. But before we dive into live views, I want to briefly compare and contrast traditional multi-page applications and single-page applications. First, let's consider the user experience these 2 types of applications can offer. Traditional multi-page apps can offer a decent user experience for simpler applications, but you'll never be able to create rich applications like Gmail, Google Maps, or Google Sheets. If I were to plot the maximum potential user experience for multi-page apps, I'd say it's pretty low. In other words, you're very much limited in what you can achieve. Okay, what about the potential user experience of single-page apps? How does it compare with multi-page apps? Well, odds are you already know the answer to this. You can create a much richer user experience with single-page apps, and I'm not even going to bother explaining why, because I don't think what I'm claiming is controversial at all. Next, I want to consider the complexity for both of these options, starting with multi-page apps. Relatively speaking, the complexity of multi-page apps is pretty low. You're more than likely using just one language on the back end, and the tools you use and the build processes are relatively simple. Now let's consider the complexity associated with single-page apps. Well, to start, you're probably still going to need to write server-side code for REST APIs or GraphQL, and possibly some other things like WebSockets or background jobs. In fact, I'd say the complexity associated with multi-page apps still mostly exists in single-page apps, but as you probably know, single-page apps add a whole bunch of additional complexity because of all the front-end related technologies. For example, odds are you'll have to add JavaScript or TypeScript or Elm or PureScript or whatever front-end language you use. Then you'll be adding frameworks and libraries like React or Vue. Plus you might decide to add a state library like Redux, and you're adding testing libraries like Jest, and transpilers like Babel, and dozens of other libraries, and each of these frameworks and libraries adds hundreds or potentially thousands of their own dependencies. So the bottom line is, with single-page apps, you can create a really rich user experience, but you're significantly increasing the complexity. Now, obviously, these two choices here and here aren't the only options. You could use multi-page apps with something like TurboLink or Unpoly.js, which can give you a slightly improved user experience, but these libraries can't provide anything close to what a single-page app can offer. And of course, you could try to use something like jQuery in a multi-page app, but I have yet to see a good code base that uses jQuery extensively, so good luck with that. It would be kind of nice if there was a good alternative to these two extremes, which offered the potential for a very rich user experience, while at the same time maintaining a low overall complexity, right? Well, it turns out there is an option that offers this exact UX complexity profile, and that option is Phoenix LiveView. Okay, so what exactly is Phoenix LiveView? Well, I'll explain what live views are in a moment, but first I want to describe a simple mental model for single-page apps, and then I'll describe how LiveView is kind of similar, but different. So when a browser makes an initial HTTP GET request to a server that's hosting a single-page app, HTML is returned. Then the browser requests the JavaScript and CSS that's referenced in the HTML file. Now, if the single-page app doesn't support server-side rendering, which most don't, then the client may have to fetch some additional data from the server before it can render a view in the browser. Okay, let's take a slightly deeper look at the parts that make up a typical single-page app. I think you can break a single-page app into roughly 3 parts: the data model and state, client logic, and view-related functions and/or templates. Now, a single-page app still needs to talk to the server, usually to send data back and forth via HTTP, but there might also be a WebSocket to support real-time features. Okay, with this simple model in mind, let's start to look at what Phoenix LiveViews are and how it works, and we'll see how LiveViews compare to single-page apps. When you make an HTTP request to a Phoenix LiveView URL, what's sent back from the server is the page's fully rendered HTML, which is really nice for SEO, and it provides a much faster initial page load versus a typical single-page app. Now, what I've described so far isn't any different than what you get with a traditional multi-page app. However, this is where the similarity ends. Well, let me explain. Immediately after loading the LiveView page in the browser, a WebSocket connection is made to the server. Now, you see these parts right here that exist in a single-page app, the model or state, the client logic, and the view parts? Well, these exist in a Phoenix LiveView, but they don't reside in the browser. They actually live in the client-specific process on the Phoenix server. Okay, so how does this work? Well, let's imagine a very simple example application, a basic counter with an increment and decrement button. So what's the data model or state for this application? Well, really it's just a number which represents the current count. In this simple example, we'll say the count should start at 0, and keep in mind this state, the count, lives on the server. So what goes here in the client logic? Well, in this simple app, we need to handle 2 things, incrementing and decrementing the number. So there will be 1 or more functions to handle these 2 actions or events. Now, this last part here, the view or template parts, is just a function in template that renders HTML that kind of looks like this. Okay, so what happens when the plus button is pushed? Well, it generates an event similar to what a single-page app would do, except this event isn't handled on the client side. It gets passed from the browser to the server via the WebSocket. Then the event is handled by a function on the server, which changes the state from 0 to 1. Now, the server keeps track of state changes, and when it changes, the server automatically calls the view-related function to effectively render a new view based on the newly updated state. Then the new view gets pushed down to the browser via the WebSocket connection, and it's loaded into the DOM. Actually, the entire view doesn't get pushed down to the browser like I just depicted. The view rendering process is optimized to minimize the amount of data sent across the WebSocket, but thinking about it as a new view being generated on the server and sent back to the browser is effectively what happens. Okay, I bet you've got questions about what I just described, so let me answer what I think some of your bigger questions might be. You might be wondering about this client or LiveView process that's running on the server, and you might be thinking that this is crazy and it's not going to scale very well when you have lots of users. Well, keep in mind that Elixir processes like this LiveView process aren't processes or threads like you might be familiar with in most other popular programming languages. Elixir processes are very lightweight And it's very common to have tens of thousands, hundreds of thousands, or even millions of these processes running on a single server. In fact, several years ago, the Phoenix team was able to load test a single Phoenix server with 2 million concurrent WebSocket connections and the associated processes. Here's another question you might have. How efficient is sending the browser event to the server, rendering the view on the server, and pushing the view update back down to the client? Well, I've described this process in a simplistic way, but the actual implementation is optimized by tracking state changes and using diffing algorithms both on the server side and the client side, so it actually works surprisingly well. You might also be concerned about the latency associated with sending events to the server and having the view changes pushed back down to the client. Well, this might be a warranted concern for users who are on a really bad, slow network connections that have lots of dropped packets. However, for users on typical high-speed internet connections, this likely won't be an issue unless maybe you're using LiveView to write games with high frame rates and significant amounts of network traffic. But even in these situations, LiveView works surprisingly well. I'm going to pull up the chart I showed you earlier to emphasize something. Now, the counter example I just walked you through is pretty simple, and it's hard to call this a rich application, but if you extrapolate the concepts I described, I think you can start to imagine the types of things you can do with Phoenix LiveViews. You can build much richer applications with Phoenix LiveViews while at the same time keeping the overall complexity low because you're only using one language, Elixir, and you're avoiding all the front-end technologies associated with single-page applications. Now, to be clear, there isn't parity between these two choices. There are some things you can do with single-page apps that you just can't do as well with LiveViews. For example, I don't think you'd be able to implement Google Maps with LiveViews. And you can't create offline apps with LiveViews. However, I bet the majority of single-page apps in existence today could probably be implemented as LiveViews instead of single-page apps. I don't know about you, but I really like this profile you see here. Essentially, you can build rich user experiences while minimizing complexity. Seems like a potential win to me. Now, I don't usually quote Linus Torvalds, but this quote seems appropriate. Talk is cheap, show me the code. Okay, well, let's create a simple counter using Phoenix LiveViews. Before I get started, I've got a suggestion for those of you who don't really know Elixir. I won't actually be writing all that much code, maybe 20 or so lines, but you're going to see some data types that you might not be familiar with, and the functions that I write might seem kind of odd as well. In the interest of time, I'm not going to explain in great detail every bit of code I write, but I think you'll be able to understand the gist of what the code is doing, even if there are certain parts of the code that you don't fully understand. Okay, the first thing I'll do is create a new Phoenix project by using the mix command, which is the Elixir build tool. Then I'll key phx.new. Then I'll name this project counter, and I don't want to use a database in this project, so I'll add the no ecto option, which excludes the ecto database library. Next, I'll say yes to install the dependencies. To use LiveViews in a new Phoenix project, like we just created, there's a few one-time setup steps that you'll need to perform to configure the project. To set this up, I'm going to follow this procedure from the LiveView Git repo, essentially copying and pasting a few lines of code or configs into a few different files. Now, I'm not going to walk you through each of these setup steps, because I suspect these steps will be streamlined in the near future, and then of course you can pull up this recipe and cookbook it yourself, so I'll perform these setup steps off screen. Okay, after configuring the project for LiveViews, I'll open the router file, which is in the directory lib-counter-web. I'm going to add a routing rule on this line right here by calling live, and I'll say when the URL is /counter, then handle this request with a module named counter-live. So you might be wondering what a module is. Well, as a beginner, you can think of it as a container or a namespace for functions. This counter-live module doesn't exist, but we'll go create it right now. I'm going to create a new directory in the counter_web directory named live. Then in the new live directory, I'll create a new file named counter_live.ex. This is the file we'll use to create the LiveView module I just referenced here in the router file. Next, I'll define our module by keying def module, and I'll name it counterweb.counterlive, which again is the same name we used in the router file. Then I'll key do and end to delimit the start and end of the module. Now I'll key in use phoenix.liveview, which essentially sets this module up to be used as a LiveView module. Next, I'm going to write a special function named mount, which receives a session parameter that I'm not interested in using, and then it takes a socket parameter. This mount function will get called once when the LiveView's WebSocket first connects to the server. I'm going to set the initial count for the counter app in this mount function, and here's how I'll do it. I'll key socket equals, then I'll call a function named assign, passing in the provided socket. Then for the second parameter, I'll enter an atom data type named count, and I'll set its initial value to 0. This line right here basically adds our stateful value, the count, to the socket data structure. Now we need to return the socket from this function. Well, actually, we need to return the socket and one other value. When you need to return more than one value from a function, you'll typically wrap the values in what's called a tuple. So I'll create a tuple by keying a set of curly braces. Then for the first element of the tuple, I'll add the OK atom, and the second element will be the updated socket. Since this tuple is on the last line of the function, it becomes the return value. Next, I'll define another special function, the render function, that takes an assigns parameter. This assigns parameter is what's called a map in Elixir. Essentially, it's a key value data structure that contains our stateful count. Now, in this render function, I'm going to use something called a sigil by keying a tilde, capital L, then I'll create a multi-line string by keying 3 sets of double quotes. Okay, so what's this sigil thing? Well, this particular sigil allows you to add an inline HTML template, which will get displayed in the browser. You don't have to write your HTML templates like this, but in this simple example, it's a pretty good option. So for the template, I'll add an h1 tag, and I'll say count, and I'll use a special embedded Elixir tag to inject the count by keying @count. This @ essentially pulls the count out of this assigns map. Next, I'll add a button that shows the plus sign, then I'll add a button that shows the minus sign. Let's see if this works in the browser. So I'll save our files, and in the terminal, I'll start the server by keying mix phx.server. Then I'll open up the browser on localhost port 4000. Now, what you're seeing here is the default page that's automatically included in newly generated Phoenix projects, but for us to use the LiveView we just created, we need to navigate to the path /counter, and as you can see, the count is 0, and we've got a plus and a minus button. If I click on the plus and minus buttons, well, nothing happens because we haven't configured these buttons to work with Phoenix LiveViews, so let's go fix that. To get these buttons working, I've got to do 2 things. First, we've got to add a special attribute to the button named phx-click, and I'll set its value to the string increment. Adding this particular attribute sets this button up to send click events back to the LiveView process that's running on the server, but now we need to add a LiveView function to handle this increment click event. So I'll define another special function named handle_event. The first parameter will be the event name, in other words, this name you see right here, increment. I'm going to do something in this first parameter that'll probably seem kind of weird if you're unfamiliar with Elixir. Instead of putting an identifier here like message, I'm going to key in the literal string increment. I'll explain what's happening with this first parameter in a moment, so just hang with me. I'm not interested in the second parameter, so I'll just key in the underscore, and the last parameter is the socket that contains the state of our LiveView. In the body of this function, I'll create a count variable, and I'll bind it to the current count, which can be accessed by keying socket.assigns.count, then I'll add 1 to it. Next, I'll update the socket with the newly incremented count by keying socket equals, then I'll call the assign function again, passing in the socket, the field name count, which again is an atom data type, and lastly, the updated count. Now I'll return a tuple with the no reply atom and the updated socket. Okay, so here's the gist of what we just did. When this button is clicked in the browser, the event is sent back to the server over a WebSocket, and it's handled by this function here, which increments the count. Now, since the state of this LiveView has changed, this render function will automatically get called, and effectively a new view will be generated and sent back down to the browser. Let's try this out in the browser. So I'll click the plus button a few times, and the count is incrementing. Cool. Of course, the minus button doesn't work, but we'll fix that right now. So I'll add the attribute phx-click, and I'll set it to a new event name of decrement. Next, I'm going to copy the handle event function. Then I'll change the event literal from increment to decrement, and I'll change the plus sign to a minus sign. Okay, if you're new to Elixir, you're probably looking at these two identically named functions and wondering what's going on here. Well, in Elixir, you can have multiple function clauses with the same name, and the way this works in this particular case is if the first parameter passed into the handle event function is the string increment, then this function clause gets called. However, if the first parameter is decrement, then this function clause gets called. Okay, let's go see if this works. So I'll click the plus button a few times, and that works. Then I'll click the minus button a few times, and that works as well. Cool. I'm going to open up the developer tools, and we'll take a peek at the data that's being sent on the WebSocket. So I'll click the plus button, and as you can see, a message is being sent to the server, which represents the button click event. Then you immediately see the response frame right here. Notice that the response isn't HTML, it's just the new count, which you can see here. If I push the plus button again, you see another increment request goes to the server, and you see another response with a new count of 2. So as you can see, very little data is sent back from the server. Let's go watch the DOM elements when a view update happens. Keep your eye on this part right here. When I click the plus sign, notice that the entire DOM isn't replaced, only the part of the DOM that needs to change is updated. It's pretty efficient. Okay, I've barely scratched the surface of what you can do with Phoenix LiveViews, but hopefully you've got a pretty good sense of how it works. Alright, LiveView is a pretty cool new technology, and I'm very bullish on it. I think it hits a sweet spot in that you can build very rich applications without adding much complexity. Let's circle back to the basketball scorekeeping app that I talked about in the beginning of this video. So how could we use LiveViews for an application like this? Well, each of these pages could be a live view. Then I'd probably keep the state of each basketball game in a separate long-running process. Then when a player scores, the scorekeeper page would send an event back to the server's LiveView process, which could then send a message to the game process. Then the game process could send messages to these two LiveView page processes. Then the LiveView processes would update their state and push the appropriate view changes back down to the browser. If you're new to Elixir and Phoenix and you'd like to learn more, you should check out my new course, Elixir and Phoenix for Beginners. You'll find a link to the course on this page. Also, if you want to be notified when I release new videos like this one, you can join my mailing list at knowthen.com/join. Hey, thanks for watching this video, and I hope you found it helpful.